to find the asymptotes. So, the vertical asymptote, the one down here, the vertical asymptote is what makes the denominator equal 0. That's all we look at. What makes the denominator equal 0? So, when we're looking for the vertical asymptote, when we find that, that's what we are done. We're done with that. Now, there's, whenever we deal with horizontal asymptotes, we have to worry about whether the degree of the numerator, that's the exponent on top, is smaller than the degree of the denominator, or equal to the degree of the denominator, or greater than the degree of the denominator. So, we're always talking about the exponent on top of the fraction. So, if we have an exponent on top of the fraction, and we have an exponent on the bottom of the fraction, it has to be either smaller, equal, or greater, right? That's the deal. So, this one says if the exponent on top is larger, then you're going to have an oblique asymptote. So if I had x to the 3 up here plus something, 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 and then I had x squared down here plus something, 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 then I would get a line as my asymptote. So this is a slanted line, right? Whenever the degree of the numerator is smaller, so if I had x plus something up here, and on here I had x squared plus something, something, something. So the degree of the denominator is larger. This one's x squared, right? And that one's just x to the 1. Then the horizontal asymptote is always 0. So this is the tricky one. Whenever they're the same, it's the ratio of leading coefficients. So if they both were x squareds, or if they both were x's, or they both were x cubes, the top and the bottom, the exponent on the top and the exponent on the bottom, if they're equal, then I have a ratio of the leading coefficients. So, what does that mean? Let's find out. Let's do a couple. Maybe 3 or 4. Maybe more. What do you say? Well, we'll do at least 4, huh? Okay, so I want to get rid of all my writing. So let's see if we can't. Well, that's pretty slow, isn't it? Oh, there we go. I got rid of all my writing. Now here we go. Let's do 4 examples, and then we'll be happy little campers, huh? Here we go. First example. X plus 1 divided by 2x squared plus 5x minus 3. Okay, here the exponent on top is smaller than the exponent on the bottom. Right? We know that for sure. What does that mean? That means the horizontal asymptote is y equals 0. Bing, 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 bing. Hey, what's the vertical asymptote? Well, I have to figure out what makes the denominator equal 0. So I'm just going to use my quadratic formula. Quadratic, where is it? Boom, 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 boom. Quadratic formula 2, 5, and negative 3. There we go. Hey, one of the asymptotes is at x equals 1/2, and the other is at negative 3. So I know what this graph looks like without even negative 3, 1/2, horizontal asymptote right down the middle, right? So I'm going to have a graph over here, a graph over here, and then a graph here somewhere in the middle, right? All I have to know is where are the horizontal and vertical asymptotes, and I know more or less what the graph's going to look like, right? So, what do you have to do? You have to tell me the horizontal asymptote, you have to tell me the vertical asymptote, and you have to tell me the domain. Remember, this is all you care about when you do the domain. So the domain is every number up to 1/2. Everything in between 1/2 and 3. And then everything at, whoops, I goofed up. Let's start all over. This is negative infinity to this first asymptote's at -3, right? Then from -3 to 1/2 is the next asymptote. And then from 1/2 on to infinity, that's the domain. Since there's 3 pictures, there has to be 3 domains. We got it. Let's do another one. Okay. So, let's do the one that has them the same. How about y equals 2x plus 1 and x minus 3? So now, the top exponent, this is 1, and the bottom exponent, this is 1. They're the same, all right? Now, according to my rules here, if they're equal, it's the ratio of leading coefficients. Ratio. What does that mean? Well, that means the numbers that are in front here, right? So we don't care about these numbers. We don't care about anything. We just care about the number that's in front of this is 1, and the number in front of that is 2. What's the horizontal asymptote? Y equals 2. What? Well, that's right. That means that it's going to come and go right there, right? How about the vertical asymptote? Oops, I scribbled out everything. Guess I better write that down again, eh? 2x plus 1 and x minus 3. The vertical asymptote happens what makes the bottom equal 0. Well, that's easy. X minus 3 equals 0. 3 is the number. X equals 3. So 1, 2, 3. So now I know my graph looks like this, and this. And so what's the domain? Since there's 2 pictures, I know it goes from negative infinity all the way to positive 3. And then from positive 3, this other domain starts at 3 and goes to the right. Boom! We always go from left to right. Let's do that again. What if we had, let's see, what is this? 3x plus 1 and then 2x minus 1. Oh my goodness. Well, let's make it x squared just because we can, huh? Okay, so is the top equal to the bottom? Yes. I mean, what am I talking about? The exponent on top is equal to the exponent on the bottom, right? Well, that means that the horizontal asymptote is the ratio of the leading coefficients. That's these two guys, right? So the horizontal asymptote is y equals 3 over 2. That's just 1.5 if you were wondering. Here's 1, here's 2. 1.5 would be right there. That's all it is. What's the vertical asymptote? It's whatever numbers make this equal 0, right? Whatever numbers make this equal 0, let's just see, what are those numbers? Now, I'm using my quadratic formula, and we're going to say 2, 0, and -1. Woohoo! So, it comes out to be nasty little decimals, but hey, they can be the asymptotes can be positive 0.707 and negative 0.707. Where is that? Well, if this is 1, that's -1, then this guy is going to be like that, right? So, what's going on? I still have a picture right here. I still have a picture right here. And I have another picture right here. I've got 3 pictures. So that means I have to have 3 domains. Right? So what's the first domain? All the numbers from the left side, -8. Let's try again. From negative infinity all the way up to the very first -1, -707. Coolness. And then there's a picture in between there, negative 707 to positive 707. And then from that one to the right, there's another one, from positive 707 to infinity. So if there's 3 pictures, there has to be 3 domains. That's what we're cooking. That's what we want. Let's do one that has an oblique asymptote. Ho, ho, ho. Oblique asymptote. What's that? Okay. That's where the top is greater than the bottom. X squared plus 5, and then x minus 2. How about that? All right. X squared plus 5 and x minus 2. So the exponent on top is bigger than the exponent on the bottom. That means that the horizontal asymptote is oblique, right? Oblique. I mean, there's no horizontal asymptote. There's no horizontal asymptote. It's an oblique asymptote. There can't be a horizontal asymptote if there's an oblique. This little thing says that right here. A graph cannot have a horizontal and an oblique, right? So that's what we're dealing with. So if this is bigger than this, then it's oblique. It can't be horizontal, right? That's the way it is. So how do I find it? Well, I have to divide. So I've got the number that makes the bottom equal 0 is 2. And then up here I have 1, 0, and 5. So I'm doing synthetic division, and I'm going to figure out what is going on here. Now, it does not have to end in 0, right? The remainder, we don't even care what the remainder is. This is the answer to the problem. Y equals x plus 2 is the asymptote that this one gets closer and closer to. You say, no way. I'd say, yes way. Check it out. I'll show you the graph here. What's the vertical asymptote? Well, whatever makes the bottom equal 0, so that's too easy. And then let's look at my picture. I've got a picture right here. Let's see. I typed it in there. I did indeed. And I know that y plus 2 is the asymptote, so I typed that in as well. So let's zoom in and see if we can see that. Yep. Okay, here we go. So, whoops. Oh no, what did I do? Let's say this is 2, and this is parentheses, and now that's going to wrap it. So here's one, there's the other one, and there is the asymptote. Look at that. It's in between those 2 slanted lines. That is just crazy, huh? Okay, let's see how we can graph it on our paper. All right. Back to making this the right size so we can see what we're doing, huh? So we said x equals 2, 1, 2. That is the vertical asymptote. And then we said y equals x plus 2. Now remember, that means that you go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So it looks like this. Do, do, do. And then like so. So whenever we're dealing with this graph, we've got one of our hyperbolas is down here in between these 2, and the other hyperbola is up here in between these 2, right? So there's only 2 pictures, and the domain, you remember, all you care about is what's on the left and what's on the right of this vertical asymptote. So the domain is negative infinity to 2, and then 2 to positive infinity. Ta-da! That's how you do oblique asymptotes. Let's do, probably should do another oblique asymptote if we could find one. Huh? Where would that be? I want another one. just like the other one. Oblique asymptotes. Oh, I know there was one in here that I was looking at just a minute ago. Ah, here we go. Let's do one more oblique asymptote so you can see it again. All right. Here it is. So y equals, and this is x squared plus 4x minus 5 divided by, let's see, where'd it go? I lost it. I lost it already. Oh no. X minus 3. Okay, so what makes the bottom equal 0? 3. X equals 3. So that's the vertical asymptote. I know that for a fact. 1, 2, 3. Okay, now then, this top one, I have to find the slanted line, y equals. So I'm going to divide by 3. I'm going to put 1, 4, whoops, what is that? That's not a 4, and negative 5. So 1 drops down, 3 goes here, 7 drops down, 21 goes there, and then we don't even care what this is. Turns out to be, what, 16, but we don't care. The remainder, it doesn't matter. This guy, x plus 7, is the oblique asymptote. You say, no way, it can't be. It is. It is. We can graph it. I'll show you. And then the domain we know, well, here's x plus 7. 7's way up here. And then it's going off that direction. And this one going up, 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 up. Right? So once again, my picture's in between here and in between there. Oh, what's the domain? Everything from negative infinity to the asymptote, and then from the asymptote to positive infinity. Nothing to it. So if there's 2 pictures, there has to be 2 domains. If there's 3 pictures, there has to be 3 domains. That's that. All right. See ya.